You've probably walked past the same spider web dozens of times this week. Maybe you even thought about sweeping it away. But that web was rebuilt from scratch last night. Every thread formed with a precision that took millions of years to develop. And the spider that built it is already calculating whether it needs to rebuild again tonight. This video is about what that calculation actually is. And by the time you reach the end, looking at that web in the corner will never feel the same. But before we go further, I want to clear something up. Most of what gets said about spider webs is incomplete. They're just for catching insects. True, but that's only the beginning of the story. They spin randomly. No, every single thread is the result of a decision. They're all the same. Absolutely not. Every species, every individual, every night, a different web. And once you understand what drives those differences, the way you see spiders changes completely. Because a web isn't just a trap. A web is the outward expression of that spider's mind. If asking this kind of question excites you, the rest of this channel is made for you. You can support us by subscribing. Now let's get into it. Part 1. What is silk, really? When you first hear it, it sounds simple. Silk, a sticky substance. It catches insects. But wait, because spider silk has become one of the most studied natural materials in science over the last 20 years. And once you understand why, you look at those thin threads in a completely different way. Researchers at MIT's Department of Materials Science spent years studying the mechanical properties of spider silk. What they found was striking. Spider silk is 5 times stronger than steel of the same weight. But that's not the most remarkable property. The most remarkable property is its flexibility. Spider silk can stretch up to 40% of its own length before breaking. Steel would have snapped long before that point. This combination is known in engineering as toughness. Strong and flexible at the same time, and no other natural material delivers both of those qualities this well simultaneously. So how does a spider produce this silk? In silk glands located in the abdomen. Different glands produce different types of silk. Dragline silk, sticky capture silk, wrapping silk, egg sac silk. Same animal, different formula. Different purpose for each, and the spider chooses which formula goes where. It decides which type of silk to use for which part of the web. That decision-making process is fascinating on its own. But here's what's even more remarkable. Those decisions can change every single night. Think of it this way. A cook doesn't make the same meal every day. They look at what ingredients are available, how many people are coming, is the weather hot or cold, what did everyone eat yesterday? And they adjust the recipe based on those variables. The spider does exactly the same thing every night. Which direction did the most insects come from? Which way was the wind blowing? How stable were the anchor points? And it adjusts the geometry based on those variables. The difference is this: the cook does it consciously, thinking, planning, deciding. We still don't fully understand how the spider does it, but that it does it, that is certain, and that puts this small creature in a far more interesting place than you've probably ever considered. Part 2. Why does it tear it down and rebuild? This is the question most people never think to ask. We ask these questions for you and go looking for the answers. The spider built the web. It's working, so why tear it down? But research shows this clearly. Many spider species tear down their webs and rebuild them on a regular basis. Some do it every night, some every few days. And this tear down and rebuild cycle is not the mechanical necessity it was once assumed to be. Researchers at Kyushu University in Japan studied this for over a decade. Spiders tear down their webs before significant damage accumulates, not waiting for damage to build up, replacing it before it does. That is a proactive decision. And here's what makes it even more remarkable. The torn-down web isn't lost. The spider eats the old silk. It digests the proteins, recycles them. They become the raw material for the new silk. Zero waste. A fully circular production system that evolved millions of years ago. But here's the real question. Why that night? Why that specific moment? Researchers observed spiders under different conditions to find out. Different light levels, different humidity, different temperature, different prey density, and what they found was this. Spiders make the decision to rebuild by evaluating multiple environmental factors simultaneously, not a single trigger, multiple variables being processed together. This is not a single-celled organism. This is genuinely a calculation. Part 3. Where does the geometry of the web come from? This is a question that kept spider biology researchers occupied for many years. When you look at a spider web, what do you see? A center, a spiral, cross threads, and symmetry. So how does that structure come to be? The first assumption was genetics. Spiders carry this pattern hereditarily and repeat it mechanically. Partly true, but only partly. Researchers at Oxford University compared the web geometries of spiders raised under different conditions. Two spiders of the same species, raised in different environments, produced completely different web geometries. So it isn't just genetic programming. Environmental information also shapes the form of the web. The spider measures the dimensions of the space it's building in. It assesses the available anchor points. It accounts for environmental factors like wind and vibration, and it adjusts the geometry based on that data. But there's another finding that goes even further. NASA ran an experiment with spiders in space in the 1970s. They observed how spiders built webs in a zero-gravity environment. The first webs were disorganized. The expected geometry wasn't there. But within a few days, the spiders adapted. They developed a new geometry suited to the zero-gravity environment. They learned. They aren't just running a genetic program. They can process current conditions and update the geometry accordingly. That is learning capacity. Stop for a second. In space, in zero gravity, a creature that had never encountered conditions like this before, and within a few days it developed a new solution. Let's be honest, most of us, when we get a new phone, spend a few days still reaching for the old habits. The spider adapted in space. Part 4. Is the web a data storage system? This is one of the questions spider researchers have debated most actively in recent years, and the answer leads somewhere far more interesting than you'd expect. In 2021, researcher Natalie Mortimer and her team at Johns Hopkins University published a fascinating study. They proposed that spiders may be using their webs not just to catch prey, but to store environmental information. I can almost hear you asking how. The tension levels across the web change. The vibration frequencies at different points change. These changes carry information about airflow, humidity, temperature, and insect activity in the spider's immediate environment. And the spider reads this information continuously through its legs. So the web is also a sensor network. From the outside, it looks like a trap. From the inside, it functions like a data collection system. This idea is still debated, but researchers are finding more and more evidence. And that evidence points to this. When a spider tears down and rebuilds its web, it isn't just replacing a damaged structure, it's recalibrating its data collection, updating its sensor system, building a new information-gathering configuration for the night ahead. Part 5. The nervous system and web geometry experiment. This part is different because this experiment sounds almost unbelievable the first time you hear it. In 1948, Swiss pharmacologist Peter Witt began studying the effects of different chemical compounds on spider behavior. His goal was straightforward: to understand how the nervous system responds to different chemical stimuli. His method was surprising. Witt gave spiders different chemical compounds: caffeine, a stimulant, and a sedative compound. And each time he documented the web geometries the spiders produced, the results came out with unexpected clarity. Spiders given caffeine built irregular, incomplete webs. The spiral structure broke down. The spacing between threads became inconsistent. Spiders given the stimulant built webs quickly but with geometric inconsistency. The start was fast, but coordination dropped off. Spiders given the lowest dose of the sedative compound built larger and more regular webs compared to the control group. NASA repeated this experiment in 1995, this time with far more precise measurement tools. And what they found was this: the degree of geometric disruption in the web was directly proportional to the effect of that chemical compound on the nervous system. In other words, the geometry of the spider's web reflects the current state of the nervous system that built it. The web is the visible form of the mind. Part 6. What happens at night? Now let's bring everything together. Throughout the day, the spider waits in its web. It reads vibrations. It catches prey, or it doesn't. It observes its surroundings. When darkness falls, something changes. In many spider species, the teardown begins. The old web is systematically consumed. This process takes only a few minutes. The proteins are recovered, then the rebuild begins. And during this process, the spider uses everything it gathered throughout the day. Which direction did the most insects come from? Which section of the web received the most vibration? Which anchor point was most stable? All of that data shapes the geometry of the new web. The spiral tightens slightly or loosens. The center shifts to a different point. Some anchor threads are extended, others shortened. The data collected through the night transforms into a new structure by morning, and when morning comes, a new web is waiting in the same corner. You see it, and you don't even notice that it's different from the one that was there yesterday. How many times did you walk past that web this week? That web was built from the previous night's data. Every thread was based on a decision. Every spiral was calibrated to the conditions of that specific environment. The spider in that corner works every single night, silently, in the dark, without asking you, and by morning, a new system is ready. I want to ask you something. When you see a spider web in your home, what do you do? Do you clean it away immediately, or do you leave it? And if this video opens something up for you, don't miss the next one, because we're going even deeper into the mind that builds that web, and what we find leads somewhere closer than you'd expect.